In this second video for lesson 3-6, our essential question is, how do I compare, add, and subtract mixed numbers with the same unit? So we're going to be talking about the same units again, but this time with mixed numbers. Now this is not in your workbook, so don't worry about looking for a page number. However, there is a rule here that you'll find in your workbook for mixed numbers when you're comparing them. If the whole numbers are different, the number with the greater whole number is greater. So focus on the whole numbers first. They might make it easy on you. However, if the whole numbers are the same, then you have to look at the fractions. The number with the greater fraction or decimal part would be greater. So if you look at this first example that I have for you, we have 5 and 7/10, and we're comparing it to 6 and 92/100. Focus on the whole number first. Here we have a 5, here we have a 6. Right away you should recognize that 6 is greater than 5. Again, if you line up your decimal points so that everything's lined up, you can add zeros if you need to make sure that they all have the same number of digits, and then compare them. If you think money, which one's greater, $5.70 or $6.92? Obviously, 6 and 92/100 is going to be greater. So the whole numbers might give it away without even having to think about it too much. However, what if the whole numbers are the same? Well, if the whole numbers are the same, then you have to compare just the fractions. So here I have to compare 3/5 and 4/5. Well, this time I've got denominators that are the same. And if you remember the rule, if you have the same denominator, then you compare the numerator. And the greater the numerator, the greater the fraction. So 4/5 is greater than 3/5, meaning 2 and 3/5 is less than 2 and 4/5. In this next example, once again, we have whole numbers that are the same. We both have 5 here, so we're going to have to focus on the fractions and compare them. So I have to compare 1/7 to 1/8. Now this time, the numerators are the same, the denominators are the ones that are different. So I have to compare those denominators. And the rule says that the denominator with the, I guess we could say the bigger the denominator, the smaller the fraction is worth, the smaller that unit fraction. So in this case, 1/7 is actually going to be bigger than 1/8 because I'd have a bigger section there of the one whole. Which means 5 and 1/7 is greater than 5 and 1/8. Now that we're done comparing mixed numbers, let's talk about adding and subtracting them. So this is workbook page 101. You do have this. We are going to add this very first example. We're going to add 1 and 3/5 with 2 and 2/5. Now notice I like to write my problem vertically, and you'll start to see why when we get to subtraction. So I write it vertically, up and down, and you can see the example here. Here is my 1 and 3/5. I have one whole and then 3/5 of another whole, but not quite there yet. And here's my 2 and 2/5. I have 2 wholes here, and then, and then here's my other 2/5 over here. So imagine putting this together. If I were to put this together, I'm going to start with the fraction first. I've got 3/5 here, I've got 2/5 there. If I combine 3/5 plus 2/5, I'm going to have 5/5, which is actually one whole. If you have 3 here, or imagine, let's do this. I'll do a different color so you can see it. We have our 2/5 here, and now I'm going to add another 3/5. So here's 1/5, 2/5, 3/5. That's why 5/5 is going to give me one more whole. Now that I'm done adding the fractions, now I can add the whole numbers. The whole numbers always come last. 1 plus 2 is obviously 3. So we have 3 for this set of whole numbers, and then don't forget about this whole number that we created with the 5/5. I now have 4 wholes. 1 3/5 plus 2 2/5 is going to give me 4. So remember the rules here. You have to add the fractions first. I'm going to write that down here. Let's go with orange. So add fractions first, and then add your whole numbers second. Okay? Let's see what this looks like with subtraction. Here we have 2 2/5. Let's see, 2 2/5. And we're going to subtract 1 3/5. Now notice the way they set it up. Here's the 1. Here's the other 1, which gives me a total of 2 here. Do you see how they did that? They just wrote 5/5 instead of writing 1 whole, because they know 5/5 is the same as 1 whole. So there's the 2, and then here's the other 2/5. So right now I have in this diagram 2 2/5. And from that diagram I need to take out 1 3/5. So let's imagine, I'm going to erase this a little bit. I have 2 2/5 here, and now I need to take out 1 3/5. So here's the 1 I'm going to get rid of, taking out 1. And I also need to take out 3/5. So maybe I'll just take out this section right here, because there's 3/5 to take away. And what do I have left? I have 4/5 remaining. So what would that look like when I'm working it out without the diagram? Take a look at how I set it up down here. Notice again I have it set up vertically. 1 fraction on top, 1 fraction on the bottom. Or, well, in this case, 1 mixed number on the top and 1 mixed number on the bottom. First I'm going to look at fractions first. Remember, fractions must be subtracted first. I have 2/5 minus 3/5. That's tricky. How do I take 3/5 from 2/5? How do I take 3 from 2? I can't. What I can do, however, is I can borrow. Don't forget that with subtraction you're allowed to borrow. Borrow from your whole number. So I had 2, now I have 1 whole, and I'm going to bring over that 1 whole. But the way I'm going to bring it over is a fraction. I need to bring over a fraction, but that fraction is going to represent 1 whole. So think of all the fractions that you can use to make 1 whole. 2 over 2, 3 over 3, 4 over 4, 5 over 5, 100 over 100. They all represent 1 whole. Here I'm going to use 5/5. The reason I'm using 5/5 is because I want to keep that denominator the same. I need to have the same denominator. All of my denominators are fifths, so I brought over 5/5. And you can see that's what they did in this diagram here. Let's see. Instead of 1 whole here, they wrote 5/5 because they showed you that that's 1 whole as a fraction and with that common denominator of 5. So I had 2/5 there. I borrowed 5/5. Now what do? Now I need to combine them. I have now a total of 7/5. Look here. Here's 5/5 plus 2 more, there's 7/5. So I combined the 5/5 that I borrowed with the 2/5 that was there. Now there's 7/5. And now I can do that subtraction that I couldn't do before. I couldn't originally take 3/5 from 2/5, but now I can take 3/5 from 7/5, and that leaves me with 4/5. And of course, with the whole numbers come second. I have to do 1 minus 1, which of course is 0. So all I have is 4/5 remaining. And you can see that's what they have here for the answer. They took away 1 whole and 3/5, and there were 4/5 remaining. Alright, the takeaways. So first, comparing mixed numbers. Compare the whole numbers first. It might make it easy. And if the whole numbers are the same, then you're going to have to compare the fractions. When you're adding mixed numbers with like denominators, remember everything's with the same denominator, all you need to do is add the numerators. Numerators always get added, denominators stay the same. Then add the whole numbers second. Whole numbers always come second. And of course, make sure your answer is in simplest form. When it comes time to subtract mixed numbers with like denominators, again, subtract just the numerators. Keep the denominators the same. They have to be the same. Now, this is really important. If you cannot subtract the numerators, borrow one whole from your whole number. Bring it over as a fraction with the same denominator as the other fractions. Like we borrowed 5/5, right? We borrowed one whole, but we wrote it as 5/5. Maybe you're going to bring over 3/3. Maybe you're going to bring over 8/8. It really depends on what your denominator is. Then combine that one whole that you borrowed with the fraction that was already there, so that now you can subtract the numerators that you might not have been able to subtract before. And then, of course, whole numbers come last. Worry about adding, in this case, subtracting the whole numbers and making sure your answer is in simplest form.